Hi, I'm Steve Justice. I'm the director of the Georgia Center of Innovation for Aerospace. You're watching this video today because you have signed up your high school team for the Real World Design Challenge. It's a very big challenge. It's over a 55-page document that has all this information in there that you have to try to digest and figure out how you're going to do this year's challenge. In the video today, we're going to give you some hints about where do you start, what do you do, what are the important things you have to worry about, what are some of the things that maybe aren't so important, that you shouldn't spend as much time on. But at the end of this, we hope you have an idea of where to go, what to do, what is important, what's important to put in your report, so that you do a good job on this, and we look forward to your submission in January for the statewide competition. So we'll begin our briefing today on this. We call this real-world aircraft design because we're going to give you some real-world hints about how do you fulfill this challenge, how do you do the things that they want you to do. So the challenge this year is to design a small unmanned aerial system, a system that consists of one or more fixed-wing UAVs, unmanned aerial vehicles, along with a business plan to perform the mission they've asked you to do. So that is key. You're developing a system, not just one vehicle. The mission scenario for this is that we have a lost scout at Philmont Scout Ranch in New Mexico, and you're looking for this scout. You're going to have to be looking in a 2-mile radius. It's a circular search area, and it says that the area is sized to allow line-of-sight contact between the operator and the vehicle that you're flying. So what does that tell us right off the bat? We're going to be at the center of this circular search area. And so the farthest distance that this UAV is going to be from you at any time is 2 miles. If you look at the rest of it, some of the other things in there I've underlined, minimum time. We're trying to minimize the time to find the scout, but also do it at minimum cost. And that we'll see that later in the objective function. If you look over in the box on the right side of the chart, you see that we're looking over about a 13 square mile area. And most interesting, that the ground is at 8,000 feet above sea level. As you go up in altitude, the air gets thinner, so we have to account for the thinness of the air. We're going to have a little bit bigger wings, a little bit better engine than we would if we were looking at sea level. So some of the rules and constraints that we're looking at with the vehicles, as we have to follow some of the FAA guidelines, and those are in the documents that you received from the Real World Design Challenge. One of the key requirements is that any of the vehicles, the UAVs, cannot weigh more than 55 pounds. We'll see later in the briefing that that is a key requirement. It limits the amount of payload we can carry and the amount of time we could be in the air to search for this scout. One of the other ones is that you have to have multiple antennas on the vehicle, one for the control of the vehicle, one for the video coming off of it, and maybe more. And those antennas must be separated by a minimum of 18 inches. So what does that tell us? Well, that tells us if we have a very small UAV, it has to be at least 18 inches in wingspan or length so that we have places to put our antennas. So most of the UAVs won't be that small, but again, that's something to keep in mind. The search operations are at an altitude of 150 to 1,000 feet above the local ground level. So since ground level is at 8,000 feet, that means in terms of the atmosphere, the density atmosphere, we're at 8,150 feet to 9,000 feet. We have to keep that in mind as we design our vehicles. And finally, we must be able to take off and clear a 50-foot obstacle within 300 feet from the starting position. This is either by throwing a small UAV, like many of them that were done, or taking off from a clearing on wheels. So that's something we have to keep in mind. If we look at some of the rules and constraints on the operations side, we have to keep the vehicle in line-of-sight contact. We talked about that. They provided flight control systems with GPS and all the autonomous flight controls that you're going to be able to use. That was provided in the challenge, so all the teams will be using that. One key thing, a separate link is required to download video data from the payload. So we'll see when we're talking about the sensors that for every sensor on your UAV, you have to have an additional radio to send that information down. So that adds weight, it adds complexity to your vehicle. One of the good news items about our requirements is that we don't have to account for winds. That area can be very windy and it can push your UAV off, but in this challenge we are considering a standard day, no winds, so that makes it a little bit easier. So the objective function we're looking at in this challenge, OF, is essentially the time to find the missing Boy Scout multiplied by the cost of fielding the system, and operating the system. Some key things to note in this is that you must complete an object detection event. In other words, you think you've found the scout, and then you follow that by an object confirmation event where you fly in closer, you get a better picture, and you say, yes, in fact, we have found the Boy Scout. You have to have a sequence of 4 false matches and 1 successful confirmation. So that means on your confirmation event, 4 times you're going to fly in low or zoom in with your sensor, say, look, and go, oops, nope, that's not it. That's something other than our Boy Scout. And then on the 5th one, you're successful. That's going to add time to the amount of time you're in the air and cost in the end. You also have to include the time to complete any required refueling of your UAVs. If you have multiple UAVs or even one that you have to keep up in the air. The cost, C, is the fully loaded cost, including the cost of building the system and completing that mission 20 times. So we're going to find 20 lost scouts. Now, you would think that they'd figure it out after the 2nd or 3rd lost scout, but for cost comparisons, we're going to go find 20 lost scouts in this. So we're going to be able to do that. So the scoring rubric that we have, and that lays out the points that you get for all the various questions that are asked in this challenge. Team submission is 55 points. Team engagement is 40 points. Systems design, the big point getter in this challenge, 175 points. Mission planning, the second biggest one, 70 points. And finally, your business plan for a total of 390 points. The biggest thing we can tell you is plan your time and your effort according to the points. Don't spend all your time on the business plan, only 50 points, and shortchange your systems design. Adjust your time and effort accordingly to the points that you're going to hopefully get. So if we look at your team submission, the biggest thing we can tell you is follow the rules. Follow the report. The report outline should be exactly in the order and the headers that are in the scoring rubric. This is because the judges have a checklist, and the checklist is based upon this scoring rubric. So they're looking for answers to the questions. If you don't put it in the same order or with the same headers as the scoring rubric, the judges have to go and search for your answers. And more times than not, if you make the judge go search for your answer, they won't find it. It's not necessarily in a logical place to the judges. So the biggest thing we can tell you is follow the outline exactly, and you see the orange box. Have a cover page. The second one is your abstract, and then the main headers, 1.0 team engagement, 2.0 system design, 3.0 mission plan, 4.0 business plan. Your report should have those major headers exactly like the rubric. The other suggestion we have is engage your English teachers and other resources at your school to make your report very readable. You want something that's easily understood. It's easy for the judges to find your answers and understand why you made certain decisions. So use every resource at your disposal at your high school. So the first area, team engagement. And when we talk about these different areas, you're going to see the orange boxes over on the right-hand side that give you the outline. This outline is exactly what comes out of the scoring rubric. Again, that's the best way to do this. Team engagement 1.0. This is easy points. You're simply telling the judges what you did, how you set up your team, all the various things you did to put your team together, and some of the things you did there. Team formation and project management. Simply explain your strategy, what you did, how you put your team together, who are your team members, what are their skill sets, how do those skill sets apply to the challenge. Tell them what person did most of the work on it in terms of certain areas. If you had an analyst, if you had someone who did most of the business plan, just tell them what you did there. Mentors, acquiring and engaging mentors. The Real World Design Challenge website is where you go sign up mentors, and you get points for signing up those mentors. Many teams miss those easy points. They don't make those connections, they don't sign it up, and they don't get those points. We have many Georgia mentors available on the website. Use them to get the points, but also as folks that you can talk with to help put your project together. There's lots of knowledgeable stuff there, knowledgeable people. So please use that. Don't miss those easy points. Project goal. You should restate the goals of the project clearly. Simply tell them what you're doing. Go back to the original challenge statement. List the requirements and assumptions and your assumptions you've made along the way. And tell them what are the key design decisions that you did along the way. On the tools, you are given in Real World Design Challenge some tools that you can download and load on your computers at your high school to use. They want you to describe your use of those tools in terms of installing them, learning them, and validating the tools. In other words, did the answers coming out of the tools match up with some of your other analysis? Do not avoid discussing the issues you had with using the tools and how you overcame those issues, or how you were unsuccessful in overcoming those issues. It's okay to tell them, if it's the truth, that you weren't able to successfully install those tools, explain why, or you didn't have time to learn them, or you had issues with that. That is necessary information that we use for next year's challenge. And believe me, if you are having problems with the tools, you're not the only team out there having those issues. So don't avoid telling us when you did have problems. And if you had a problem and you overcome it, please tell us that too.